Solving equations, part 2. Now that we know how to use the distributive property, we can solve some equations that are a little more complicated than the ones we did in the last chapter. Notice that in our equations we have parentheses and we have numbers outside, so before we can even begin to solve the equations, we're going to have to clear the parentheses. We do that by using the distributive property. So I'm going to distribute 5 through the first set of parentheses. 5 times 2x is 10x. 5 times 8 is 40. Now, 6 times 2x is 12x, and 6 times 4 is 24. Once we've gotten rid of our parentheses, our objective is going to be to try to isolate the variable. Now before we can get x by itself, we're going to have to get x on the same side of the equal sign. I have 10x on the left, I have 12x on the right. I need all my x's on one side, which means I need to move one of those terms to the other side of the parentheses. Generally speaking, people like the x's to be on the left-hand side, which means we need to eliminate the 12x by subtracting 12x's from the left-hand side. But whatever I do on the left-hand side, I must also do on the right-hand side. Now, technically I have 3 terms on each side of the parentheses. Make sure you follow your rules for combining like terms. The only terms that can combine on the left are the 10x and the negative 12x. 10x take away 12x leaves me with negative 2x's. Now I still have the plus 40 because it didn't combine with anything. Keep your equal sign in the same place. If I combine terms on the right hand side, 12x take away 12x leaves no more x's. No more x's means I don't have to list any term with an x on the right hand side of the equal sign. But I do still have a term of 24. Now the only term that has an x in it is the negative 2x there on the left. So now I need to work on getting that by itself. I need to get rid of this plus 40 by subtracting 40 from both sides of the equal sign. On the left, nothing combines with negative 2x, so I bring that down. Plus 40 minus 40 makes nothing. On the right hand side, 24 minus 40 is negative 16. To get x by itself, I need to divide by negative 2 and follow my sign rules. X would be positive 8. Now, you should be trying to check these. Which means I go back into my original equation, and everywhere there was an x, I'm going to plug in 8. Remember that a number bumped up against an x means times. Now I can't type this whole thing into the calculator at once, just one side at a time. So if I type in 5 parentheses 2 times 8 plus 8 and get that answer. I get 120. Now the only way I know if that's right is if I type in 6 parentheses 2 times 8 plus 4. Close your parentheses and see what you get. You also get 120. If you get the same thing on both sides of the equal sign when you check it, that means we can be quite certain that answer is correct. But there's some other interesting things that can happen here. So let's see what happens here. We're going to do this problem exactly like we did the first one. 5 times 3x is 15x. 5 times negative 9 is negative 45. On the other side of the equal sign, 15 times x is 15x. And 15 times negative 3 is negative 45. Now if we follow the same procedure, we can't have x's on both sides of the equal sign, so we're going to subtract 15x's off the left. And if we do that, we must also subtract 15x's off the right. Except I can't tell my left from my right, so same thing I said, only in reverse. Subtract them off my right, which means I subtract them off my left. But here's what happens. It really doesn't matter. 15x's take away 15x's on the left-hand side means I don't have any x's left, and I'm left with negative 45. On the right-hand side, 15x minus 15x makes no more x's, and I'm left with negative 45. Well, there's one of two things that can happen when you make your variable disappear, and you didn't do it by mistake. You examine the statement you're left with, and that statement's either going to be true or false. In this case, negative 45 is equal to negative 45, so that statement is true. If the statement is true, our equation is what we call an identity. An identity means everything works for x. So x doesn't equal all numbers, or x doesn't equal one particular number. X is equal to all real numbers. That's hard to check, but you can pick something like 2, plug it into your calculator, for x, and see if you get the same thing on both sides. Well, then turn around and do it with another number. Just pick a random other number, maybe 0, maybe 10. Any number you pick should work. Now you're not going to be able to try them all, but once you've tried a couple, that should be enough to convince you, yeah, everything looks like it works. So let's see what else can happen. 9 times 2x is 18x. 9 times negative 5 is negative 45. 3 times 6x is 18x. And 3 times 1 is 3. Again, we want to get our x's on one side. And look what happens again. X terms cancel, and I'm left with negative 45. X terms cancel, and I'm left with a positive 3. Is this a true statement? No. Negative 45 is not the same as 3. This is called a contradiction. In a contradiction, nothing works. No solution. That means no matter what number we pick for x, I will never end up with the same thing on both sides. No solution. That's what we say when we mean nothing will work.